Hello and welcome back. The goal of this module is to learn about the different functional groups, meaning the different steps of a sanitation system. You will get familiar with the different tasks of excreta management over the course of a humanitarian response. This will allow you to know how sanitation systems can be developed over the course of an emergency. During the acute phase of an emergency, minimal sanitation services are needed. We will have a look at the sphere minimal standards for excreta management in order to know the minimal objectives of sanitation during an emergency. There are several different subgroups of sanitation during a humanitarian response, including wastewater management, solid waste and healthcare waste management, excreta disposal, dead body disposal, and hygiene promotion. The definition of sanitation by WSSCC considers excreta, wastewater and solid waste management as part of the sanitation domain. In these modules, we will focus on wastewater management and excreta disposal, meaning all sanitation domains linked to the waste disposal from the use of toilets. During an acute humanitarian crisis, the protection of public health is the main goal of sanitation. A public health crisis in the form of a cholera epidemic or other feces-related diseases must be avoided. Conflicts of interest between public and environmental health can arise. For example, vacuum trucks might dispose untreated fecal sludge into the environment due to the lack of treatment facilities, in order to get it away from settlements and protect human health. While this practice can be justified during an acute humanitarian crisis, the protection of environmental health, along with social, institutional, and economic considerations, should not be overlooked and tried to be addressed as soon as possible or even integrated from the beginning. Finally, the reuse of sanitation products can become a goal during the post-crisis when new systems are implemented. What are the functional groups of a sanitation system? A sanitation system is more than just a toilet. There are other functions that need to be covered. Let's have a look at the system on this slide and how different sanitation products move through the system. What you see is a dry toilet over a single ventilated improved pit. The excreta, indicated by the black arrow, is emptied and transported manually to a transfer station outside the neighborhood or, for example, a refugee camp. From there, a truck takes the sludge to a thickening pond, where the sludge settles to the ground and the clear effluent stays on top. Effluent, now shown with a blue arrow, is further treated in waste stabilization ponds, while the sludge, shown with the brown arrow now, is put onto planted drying beds. Once the sludge is dried, it can be applied in agriculture. The now treated effluent is added to the groundwater. Now, how can we categorize these technologies and approach the mess on this slide in a systematic manner? In the compendium of sanitation systems and technologies, we categorize all sanitation technologies into 5 different groups with the color code as seen on the image. A sanitation system always consists of a combination of technologies from several or maybe even all of the 5 different categories. The first functional group is called user interface, meaning the toilet itself, so the interface between the user and the rest of the sanitation system. This can be a dry toilet, a flush toilet, or a urine diverting toilet. Sanitation products have to be collected and stored on-site in some systems. Therefore, the name of the second functional group indicated by the color orange. There, some treatments can already occur. A widely used technology from this category is the septic tank. In the septic tank, some physical separation of sludge and effluent occurs and some anaerobic degradation. Once the collection technology is full, the sanitation products need to be emptied and transported. This yellow category is called conveyance. All sanitation products need treatment. Thus, all treatment technologies are categorized in the 4th green functional group, and finally, they can be safely reused or disposed, as indicated by the blue functional group called use and disposal. If you want to find out more about this, please check out the compendium of sanitation systems and technologies, where all of this is explained in more detail, or check out the other online course by EAWAG. During a humanitarian crisis, resources are limited and sanitation systems break down, are inexistent or have been destroyed. It is therefore not feasible to implement a complete sanitation system from the very beginning, that takes into consideration all functions. The sphere standards provide guidance on the minimal standards for excreta management during a humanitarian response. This can help to set priorities and provide minimal services. There are 2 standards for excreta management in the sphere guidelines, which we will have a closer look at. The first goal of excreta management is to create an environment free from human feces, meaning that all living areas are free from fecal contamination. The first key action is to implement appropriate excreta containment measures. With the lack of resources, this can mean a cleanup campaign, the demarcation of defecation fields, and the construction of public toilet facilities. All of these actions have to be implemented in consultation and coordination with the affected community, as they have key information from the ground and will be the ones to use the facilities. Sanitation facilities have to be constructed away from water sources and not too close to the groundwater table. Locations downstream of rivers or at the bottom of a slope are therefore preferred. The second minimal standard in sphere is the safe containment of excreta. The standard says that all affected people should have adequate, appropriate, and acceptable toilets sufficiently close to their living spaces to allow rapid, safe, and secure access at all times, day and night. There are 3 key actions to take in the first step: consultation with the affected community on the planned actions and the provision of adequate toilets and hand washing facilities. But a toilet is not just a toilet. There are several functions that a toilet has to fulfill in order to qualify as adequate, appropriate, and acceptable. A toilet has to be inclusive to everybody, including elderly people, people with reduced mobility, pregnant women, children, staff, and everyone else. A toilet should be safe to use and provide privacy. This can be achieved by constructing public toilets not more than 50 meters away from dwelling, by sex-segregated and lockable toilets. Furthermore, it has to fulfill basic hygienic functions such as the possibility for menstrual hygiene management, at minimum through the provision of water and a solid waste bin with a lid. Also, hand washing facilities and avoiding that the toilet becomes a breeding nest for flies and mosquitoes is needed. It should be ensured that the toilets can be emptied when full and that transport, treatment, and disposal or reuse of sludge is warranted. Toilets should not be a source of groundwater contamination. For public toilets, there should not be more than 50 people per toilet in a female to male ratio of 3:1. However, the goal of any long-term intervention is to provide household toilets which are organized by the community themselves. Many prolonged humanitarian responses require an action plan that goes beyond quick fixes and immediate interventions. A long-term action plan is needed after immediate actions were implemented. This includes the rehabilitation of existing infrastructure or the construction of new one. Implementation can be done stepwise with services that are upgradable. Constant monitoring is required in order to assure the success of the steps. Especially in the acute phase of an emergency, public and environmental health threats need constant surveillance. The data for monitoring can be gathered through community surveys, observations in the field, and expert interviews. As mentioned before, sanitation systems have to fulfill different needs during different phases and types of a humanitarian response, which can require different technologies and services than those needed at a different stage. During Croning crisis, these different phases cannot be distinguished and several interventions might have to be implemented at the same time. In the following example, the goal is to show how sanitation systems can be developed over time. This fictional example of an armed conflict forces a city's inhabitants to flee their houses and resettle in an isolated rural area. Water supply is not yet provided, and the first goal is to provide a quick fix sanitation solution that serves a large amount of people and that safely contains excreta from human contact. The proposed first step is to implement public shallow trench latrines together with hand washing facilities next to the latrines so that the first standard of sphere can be fulfilled. These interventions are complemented with a hygiene awareness campaign in order to educate people on public health threats and to stop open defecation. We will develop the system in this example with the terminology of the 5 functional groups from the compendium. Shallow trench latrines can be implemented quickly using local materials. Little construction work is needed. The shallow trench latrine will be explained in more detail in a later module. The public shallow trench latrines will fill up quickly and adequate treatment and disposal is needed. On-site lime treatment can help to hygienize the excreta. Afterwards, the trenches are filled and covered and the site must be decommissioned and secured. This will help to prevent human contact with the contained feces in the long term. After the acute phase is over and more materials, skills and capacities enter the newly formed refugee camp, more appropriate sanitation solutions can be implemented in parallel to the public shallow trench latrines. A raised latrine can be constructed with a holding tank below, as more material like tanks and toilet user interfaces are now entering the affected area or have been produced or organized locally. On this image behind me, you see such raised latrines, with buckets beneath that can be emptied easily. In the forefront, a simple hand washing facility provides the necessary hand hygiene after defecation. These public latrines were implemented in Haiti. As these holding tanks fill up, a conveyance method is needed. Vacuum trucks will empty the holding tanks, dispose the fecal sludge in an adequate distance from the human settlement, as no treatment system is yet in place. This simple service extension further can guarantee public health in the camp. As there are still no treatment options available, the waste is disposed in the form of surface application without treatment. This is not an ideal situation as it threatens environmental health. This leads to the next extension of sanitation services. The goal now is to provide an improved sanitation system that covers all steps of the sanitation service chain, is appropriate to the urban community living in the camp, and that provides toilets on household level instead of public toilets. Furthermore, the system needs to be upscalable and resilient to future acute humanitarian responses. Therefore, pour flush toilets are constructed at a household level, as the urban community is used to the water-based sanitation systems and will not accept dry sanitation systems in the long term. Septic tanks are constructed in a first step. To treat the sludge from the septic tank and the holding tanks, unplanted drying beds are constructed before final disposal in the form of now safe service application of sludge. The effluent from septic tanks is disposed in the ground without treatment at this point. As an intermediate step until unplanted drying beds can be constructed, some short-term sludge treatment facilities can be implemented, such as sun drying beds like the ones on the image behind me, implemented by Oxfam during the 2014 emergency response in the Philippines. Finally, a simplified sewer can replace transport of the effluent from the septic tank to treatment in waste stabilization ponds. The raised latrines can still be used in public places such as schools, markets, health centers, etc. Please note, due to time constraints, that we only talked about the technology part of the sanitation system. However, as you know, a sanitation system not only consists of hardware but also software. This has to be developed as well. Users need to be informed and involved, staff needs to be trained, financing of the system has to be secured, including for operation and maintenance. All of this takes time and resources and has to be taken into account. This example shows just one way of how a system can be developed. This development always has to be based on many different criteria in order to select the best fit and the most appropriate system. The criteria will be introduced in more detail in another module. In this module, you have learned why sanitation service delivery is crucial for maintaining public health during humanitarian crises. You've learned about the different functional groups that are needed for full sanitation service delivery. We then had a look at the sphere standards for emergency excreta disposal. Please remember that these standards are minimal standards for an acute humanitarian crisis and that implementing them will not provide a complete sanitation system. You will have to upgrade the sanitation system over the course of a humanitarian response as the needs will change and there is no one-size-fits-all solution to sanitation. We had a look at one fictional example on how to develop a sanitation system over time. I hope you've learned a lot. Thank you very much for your attention, and if there are any questions left, please go to the forum where we can discuss together on the topic. Thank you very much.